What do we do to become the best in the country?
There's very, very few schools that would have a flight research lab. It's very rare.
I just kind of sat there and thought, wow, this is going to be a big deal.
It wasn't a plan. There was no plan.
These things just don't happen to most folks.
Sometimes I kind of think it's almost a miracle at Mississippi State. We have an aerospace engineering program. This was about 1932. Well, at the time, aeronautical engineering, they weren't sure if they were supposed to start it. There was a message from the governor's office that said, okay, start teaching aeronautics classes. And the president of the university they weren't quite sure what they meant. Did they actually intend for Mississippi State to start a aeronautical engineering program? So they started 1934 academic year. It wasn't until the fall of 1934 that they basically were split off into a separate department. During World War II, the department didn't shut down. It got down to two faculty members, Kenneth Withington, who was the head, and Sumter Camp, and then Franklin Edwards joined them, and then Sumter Camp got busy teaching pilots at the flight school, so he pulled out, and then Withington got called in to the Army Corps of Engineers. I just left Franklin Edwards. There was a lot of work being done on compressible flow, and kind of research labs, airplanes. So you start seeing these developments in the curriculum, in the course descriptions. The faculty at Mississippi State were well aware of what was happening with regards to high-speed flight, compressible flow, shock waves. They were definitely keeping up with the times.
When you're in a university environment, you're dealing with interesting people. Well, for example, Dr. Raspet. I knew Raspet had children who were 2 years older, 2 years younger, and then somewhat younger, Ricky. And Raspet was not a native. So in the 50s, everybody at Mississippi State was pretty much a Southerner. And there wasn't a lot of outside influence until you got people like Raspet in here.
He was looking for a place to do research. At that time, the airport was abandoned, and it had just a terrible old handmade Quonset hut hangar. And but Raspet was willing to put up with that. And then they thrashed around just for a little while, and pretty soon he had contacts in Washington in the DOD. He flew gliders and chased buzzards to see how they managed to fly. There was a legend that he taught a buzzard to fly in the wind tunnel. And they asked him how did he do that. He said he turned the buzzard around, gave him one look at the propeller downstream, and that's all it took. That pretty much was all there was. Low-speed aviation, boundary layer control. The whole idea was to be able to land and take off in a short distance. And in order to do that, you had to be able to fly at a low speed as you came down to the ground and still have some lift.
The Marvel project was the low-speed, short takeoff and landing airplane by the Army. It was an all-fiberglass airplane with a pusher, prop, and a shroud around the propeller, which enhanced the thrust of the propeller. Had skids on it for landing in wet ground, a few things of that nature. So that was one of the big thrusts in the early 60s. And of course, when Raspet was killed in 1962, a lot of that momentum sort of changed, and it continued, but perhaps at a different scale.
But the success of the Aerospace Department, the Raspet Lab, things that came as a derivative of aerospace like the ERC, they're all traced back to Charlie Clyde.
The department at that time was probably no more than about 4 professors and relatively small enrollment, and certainly very few facilities in the 50s. It must have been early 60s when Clyde became department head, just in time, because he was the right man at the right time to develop the staff in the department to take advantage of the research opportunities that were coming forth. And of course, he did have the Raspet Lab as a sort of a flywheel to help with momentum. So Mississippi State was in a transition for trying to hire PhDs. If you also think about the late 50s, early 60s, Mississippi didn't have the best of reputations, and the fact is you couldn't get people to come down here and interview.
Charlie made a significant decision in the early 60s. So Charlie came up with a strategy of bringing 4 of us guys who got our undergraduate degrees at Mississippi State and got master's degrees back to the faculty with only a master's degree, with the stipulation that we were going to go somewhere else in a few years and get a PhD and come back. So I went to Georgia Tech. John McWhirter and George Bennett both went to Illinois. David Murphy went to Wisconsin. The 4 of us came back, and Charlie had 4 PhDs in his department.
The department was always sort of under the gun in terms of enrollment. The first thing that comes to mind is 1973. The Apollo program had peaked. The supersonic jet had been canceled, and the industry was in a massive decline. And our enrollment went down. Research dollars were hard to find, and there was talk of closing the Raspet Lab. And we had a faculty meeting, and Clyde laid it on the line. He said, "We've got to bring in some research dollars." He said, everybody's going to have to write proposals. That's our salvation. And one of the outcomes of that meeting is that we had to make a decision as to what we were going to focus on.
So Charlie said, in aerospace, you're going to do research in one of 2 areas. One is flight mechanics, which of course is the Raspet Lab. The other is computational fluid dynamics, which was me. He said, you're going to do research in one of those 2, or you're going to find somewhere else to work. And had Charlie not made both of those strategic decisions, none of this happens.
But the big projects really came under George Bennett. And the first of those that I was associated with was modifying the Marvel airplane for a consultant for the Saudi government.
We had the Marvel, and our test pilot was a guy named Gift Bull. One of his students remembered that we had done the Marvel back in the 60s. This is now in the 80s. This is 82. And he came by and says, "Y'all still got that Marvel?" "Yeah." Says, "I got this problem. The Prince Turkey Faisal, Saudi Arabia, got a problem. He needs to defend the empty quarter. Oh, needs an airplane that'll land and take off deep sand. Here we go. Think you could fix it up and put on a demonstration in about a year?" Had the old Marvel back together, flying in August, and we were in Saudi Arabia in November. Less than about, 10 months. Somehow word got around on that, and Honda showed up. And that ended up being a 10-year project, $1 million a year. Honda Research and Development decided they wanted to build airplanes. They didn't know anything about airplanes. They built cars. We ever heard of a Honda airplane? Honda R&D decided to send their engineers here to learn how to build an airplane. What goes into it? What goes into the certification? They bought a Bonanza, turbine-powered Bonanza airplane. They built a new tail for it. They built new wings. They had to learn what the certification means, what the requirements mean. They then moved on to where the Japanese designed and built a prototype jet airplane, and it was flown and tested here. I mean, the airplane made on its first flight was on the cover of Aviation Week in Space Technology. So there was nationwide publicity.
I will always be grateful to the Honda people for allowing us to piggyback on their project with educational opportunities for the students. They were very generous in that regard, and it wasn't just a development project. It was certainly a very valuable experience for many, many of our students.
You know, in deciding what do I want to do, what do I want to work on, versus what is going on in industry, what is going on in government, what are their interests, there has to be sort of a marriage of the two. Every project has to have champions, and when your champion goes away and you can't sell the idea, then that goes away. Then the question is, what do you do? There was a move to try to go more into fabrics, because the flight lab originally started with one of the first fiberglass airplanes. Then eventually the composites, carbon fiber, became popular. The lab got expertise in that. Then the UAV program became more interesting, and we have an explosion of interest. You can see it nowadays. The UAVs are everywhere. And now the question is, what do we do with it?
Aerospace missions are inherently complex. It takes a lot to get off this planet. And all of these missions enable us to seek the technologies that are going to be necessary in order to complete those missions. All of us together are working toward a curriculum that is informed by current needs, by current technologies, because aerospace missions demand that. So even right now, our new faculty, our assistant professors are making substantial contributions. We're standing up an all-weather a laboratory at Raspet Flight Lab that is going to be used for testing UAVs in inclement weather conditions. That is what's going on right now. It's going to be the first of its kind facility, and it will be located at Raspet Flight Lab. We have research that's going on in the area of autonomy. We have ongoing research in advanced manufacturing. That's the future, and we're already beginning work on this. I think it's very important to understand the legacy of innovation in this department. It is our academic DNA. It is our identity. Understanding where we've come from and the advancements that have been made in the past in this department actually propel us forward. So we must not forget from where we have come, but our eyes must be on the future and do it all in an ethical way that benefits mankind.